30 years after its commencement, the James Webb Space Telescope was sent off from French Guiana. On Christmas Day, on December 28th, it passed by the Moon. On January 24th, it terminated its motors for 5 minutes prior to entering its conclusive circle, which was 1.5 million kilometers away from Earth. Following quite a while of dreary preparation, it at long last produced its most memorable picture on July 12th of last year, showing us far-off worlds interestingly as they appeared in excess of 13 billion years prior. Since from that point forward, the Webb telescope has kept on expanding upon this mind-boggling establishment. Seemingly, the limit has been lifted again, and Webb is introducing another period of stargazing and space investigation. Its most recent photos act as convincing evidence of both humankind's ability for discovery and its complete unimportance. Join us as we investigate the new picture captured by the James Webb Telescope that reveals the secrets of the universe. In reality, telescopes are not truly looking back in time when they notice the light from far-off galaxies. Nobody can directly look at the past since it does not exist anymore. Rather, the telescopes are noticing the current pattern of a light beam. This light beam has been essentially undisturbed for a long period of time as it travels through the mostly void vacuum of space. Thus, the pattern of this light beam right now is the same as the pattern it had when it was first emitted by the faraway world billions of years ago. We can therefore deduce about the world's appearance billions of years ago by noticing a light beam in its current state. It's akin to printing out a baby photograph of your daughter and then looking at it 10 years later. You are metaphorically looking back in time when you take a look at the printed photograph to see what your daughter looked like as a child. However, you are not actually seeing back in time. Your daughter isn't a child anymore, and she doesn't have a child self anywhere in the universe. Instead, you are seeing an ongoing lighting pattern that was captured by the printed photo, as it's reflecting the light in the surrounding space. Anyway, the current light beam emanating from the image has the same pattern as the light beam that originated from your daughter many years ago because the ink in the image has been specifically arranged into a pattern resembling your daughter as a child. And because the ink pattern has not changed over the past 10 years. Like this, we can deduce the past from present sunlight radiates hitting observatories, coordinated at distant worlds. On the off chance that the light has not changed through time, a more accurate description of the past would result. The red shift that results from the universe's expansion is one important adjustment to light as it passes across intergalactic space. Luckily, since the red shift is now well known, it is feasible to move the light pattern back by the appropriate amount to give an accurate image of the far-off world at the time the light was emitted. Only a few galaxies that were previously known to exist in the period the James Webb Telescope has now uncovered many old universes that may be among the first occupants of the universe. According to a new report, these very young galaxies showed incredible patterns and star formation groups as soon as 600 million years after the Big Bang. The review is a result of international collaboration known as the JWST Advanced Deep Extragalactic Survey, which gathered data over a month from 2 discrete sites of the sky, one nearby the Forix group and one more in the Ursa Major constellation. Over 700 recently discovered young galaxies in this area give insight into the early universe. If you took the whole universe and contracted it down to a 2-hour film, you were seeing the initial 5 minutes of the film. Kevin Hain, an assistant research professor at the Steward Observatory in Arizona and a lead author of the new survey, said while announcing the discovery, "These are the universes that are starting the course of making the constituent parts and complexity of the modern world. Later discoveries using Webb's data have elucidated the origins of Earth systems and stars, which resulted in the diverse range of elements found in the universe today." PNE and his team found 717 young worlds in those 5 minutes, proving that the universe is between 370 million and 650 million years of age. These galaxies are already thousands of light years across, have intricate structures, and are birthing stars in different clusters. Previously, the earliest galaxies we could see only appeared to be small smears, but those smears represent millions or even billions of stars at the beginning of the universe. Now we can see that some of them are actually expanded objects with visible patterns. Just as all of the main space telescopes, including Hubble, Chandra X-ray Observatory, and NASA's now-retired Spitzer, have conducted significant research on the 2 regions used in this survey, collectively referred to as the Great South. 93% of the newfound galaxies that Webb found during JWST had never been noticed before. Despite this prior assessment, only the brightest, most extreme occurrences of bright galaxies from the early universe were visible to us. Now that the universe is still young and wild, we are actually drilling down to more common, everyday galaxies. There's been much discussion on how exactly that turbulent, incredibly dusty atmosphere turned into the transparent universe we know today. One popular theory holds that this phase of the universe's evolution, known as the epoch of reionization, occurred around 400,000 years after the Big Bang, when the first generation of stars, estimated to be 30 to 100 times as large in thousands of times brighter than our Sun, formed and illuminated the previously dark universe by breaking the universe's abundant hydrogen molecules into protons and electrons. This ultraviolet starlight reionized the universe, a process that lasted for 1 billion years after the Big Bang. Few researchers, however, believe that outflows from supermassive black holes, like the one in the center of our Milky Way, might have caused bright radiation from galaxies to escape and thus may have had a more significant impact on cosmic development than previously expected. Yet, a second JWST team that has been exploring galaxies between 5 and 850 million years after the Big Bang, or between 5 and 8 minutes of the 2-hour film depicting the universe, believes it has the answer to the age-old question. In this next scene of the universe, we are beginning to see the impact of experience on the production of large-scale universe systems in the early universe. Worlds in the early universe were just far more turbulent in how they formed stars. To understand how starlight ionized the gas inside those incredibly early galaxies, the team analyzed the signals of star formation in those galaxies, a property that ions ionize by starlight emitting when they have cooled and merged with other particles. The researchers found that 1 in every 6 galaxies at that point showed intense line emissions in the system range. These emission lines indicate that early galaxies were producing stars efficiently, which led to rain of bright photons being impacted into each universe. The early stars of the universe turned into the primary forces for cosmic reionization in tricky claims that in the early universe, these strong emission lines are indeed very common. These strikingly strong emission line fingerprints, which indicate intense recent star formation, are present in almost every galaxy that we have found up until now. They were excellent at creating hot, massive stars in these early galaxies. An S group concluded from the same emission lines that galaxies in the early universe gave birth to stars in a nutshell explodes and then went dormant periods. A deep process picture of many galaxies, millions of which were viewed as they were in the early universe, was the first image the James Webb Space Telescope sent back on July 22. Many people weren't ready for some of these galaxies to appear to be curiously distorted and twisted. It is an illusion in the Webb photographs. These Salvador Cart-like galaxies that look like melted candy are not how these objects appear in space. A further astonishing feature of the Webb photographs is the presence of many galaxies in the same picture, as displayed in the picture of the enormous galaxy cluster RxJ 2029. This is a fancy. These galaxies don't actually have identical twins. How is that even possible? The same gravitational lensing system is what causes these two separate Webb picture highlights. Albert Einstein's original prediction of gravitational lensing, what capabilities as an amplifying glass for space astronomers, was made over 100 years ago. They are examples of gravitationally lensed objects that are twisted and repeating galaxies. Einstein's theory of general relativity battles that mass-having objects have an effect on the texture of existence, which is combined to form a single entity known as spacetime. Gravitational lensing can be envisioned as an extended elastic sheet covered in wads of varying densities. The elastic sheet is more seriously distorted by a ball with a larger mass, like how massive objects are embedded in spacetime travel, and world clusters are particularly extreme models when light from a background object like a star or universe navigates this twist. The effect becomes fascinating. Often light moves in straight lines, but when it passes through twisted space, it bends due to the way mass warps space. Hence the background object.